looking at the warm-up here. All right, so if I give you SN2S, how would we name that? Anybody think they got that one? Better? Oh, you got the answer? You just go back. All right, what do you think? 10-1 sulfide. Yes, good. Yeah. 10 Roman numeral 1 sulfide. Perfect. All right, now how you do this? Well, all right, so SN, write down the name of SN. So what's SN? Well, that's right here. That's 10. All right, now the next question you got to ask yourself, and this is, I think, where people get hung up is, you got to ask yourself, does 10 have more than one possible charge? Meaning, when you look at 10, do you see a sticky note on our periodic table telling us a charge? We don't, right? Tin and lead, they actually behave like the transition metals where we do not know the charge. That is why we have the Roman numeral. That means you're going to have to use a Roman numeral to tell us the charge of tin in this context. So looking here to figure out the charge of tin, focus on the charge you do know. You do know that sulfur has a -2 charge. So if you find sulfur on the periodic table, everything in that group there has a -2 charge. We also know, -2, we also know that charges got to add up to 0. Now, we got to cancel out that -2 charge, so we need a +2 charge. However, you have 2 10s to cancel out to get to that +2 charge. That is why each individual 10 needs to be a +1 charge. That's why it's 10 + 1, not 10 2. Another big mistake people make here is they see a 2 there, and they think, oh, I should put a 2 there. Okay, so make sure you make note of that. All right, jumping to number 2, ammonium sulfate. Who thinks they got that one? Yeah, go ahead.
It's NH4 for the ammonium, 2,
Okay.
and then SO4 because it's sulfate with an ATP.
Perfect. Oh, well, they gave us that, yeah, but anyways, yeah, no, that's how you'd write it out. NH4, 2, SO4, good. All right, so how you do this, now they give us the name, ammonium. Well, you got to know your polyatomic ions. You have to memorize this list of 7 polyatomic ions over here. Ammonium, that's the only cation. It's the only one that's got a positive charge. So it's NH4, and it has a +1 charge. So to figure out why there's a 2 there, has to do with the charges. Now we're paired up with sulfate. Sulfate's got a -2 charge. And remember, charge has got to add up to 0. 1 - 2 does not equal 0. Right? So I need a second +1 for us to add up to 0. That is why it's NH4 2. That's why you got that 2 there. All right, we seeing that? All right, jumping to number 3, iron 3 acetate. Anybody got the answer to that one? Yeah, go ahead. Love it. Perfect. All right, this one's similar, somewhat similar to the first problem, but now they give us the name. So iron, all right, we'll write the symbol for iron. Iron's a weird one, it's Fe. And then this Roman numeral 3, again, biggest mistake, people want to put the 3 there because there's a 3 there. The 3 is telling you that you have a +3 charge on the iron. Question?
No, I was just going to ask, like, could the 3, does it mean like a -3 charge or +3 charge?
It'll always be a +3 charge. The first element's always positive.
Okay.
Remember with ionic naming, you always put the cation, the thing with a positive charge first. All right, now the reason why there are 3 acetates is because if you got to memorize acetate, right? Pain in the ace, it's really long. It's a -1 charge. Charge has got to add up to 0, right? 3 - 1, that does not equal 0. So you need 3 -1s for us to cancel out that +3. So that's why there are 3 acetates. Okay, remember for polyatomic ions, I forgot to mention this for number 2, you got to have parentheses around it if you're going to have multiple of that polyatomic ion. Otherwise, you need that 3 to distribute to this whole thing. Otherwise, you'd be saying C2H3O23. Okay. All right. So the last one's CaNO3 how would we say that one? Calcium, okay, Ca is calcium. That's the first thing you gotta answer. Second question, does calcium have more than one possible charge? Meaning when you find calcium, do you know its charge?
Yes.
We do, right? So that means you do not need parentheses. You don't need to tell me the charge. You don't need to say calcium 2. It's like, what else will calcium be? It's always a +2. All right, so then jump to NO3. What's NO3? Nitrate. It's one of those you got to memorize. So the answer is just calcium nitrate. All right, so that's ionic naming. Now let's jump to covalent naming. And what you'll see here is it's actually a lot easier for covalent naming. Now this slide actually isn't about covalent naming. I showed you this slide earlier. This is just kind of another slide to kind of like maybe help you reason through ionic naming. I'm not really going to dwell on it too much, but what is nice about it is this right-hand portion of the slide is what we're going to talk about today. Meaning, if the first element is not a metal, that's when we do covalent naming. Whereas when we did ionic naming, we do ionic naming whenever the first element is a metal. So, let's get into covalent naming. So everybody got the notes? Everybody writing down? You got some blanks in this slide? All right, so everybody should be writing here. And you should have the first 4 of the formulas filled in. Okay, so the idea of covalent naming is, going back to that slide I showed you just a second ago, if the first element is not a metal, that is whenever you do covalent naming. So the idea of covalent naming is you're going to have to, the first element is going to be a non-metal, and the one that goes first is the one that is closer to the bottom left of the periodic table. Another way of saying that is the element that is less electronegative goes first. If you remember electronegativity, how badly the atom wants electrons, we said that increases to the top right. So you're closer to the top right, you are more electronegative, assuming you get rid of the noble gases. That's why if you are less electronegative, meaning you're closer to the bottom left, you go first. Typically, you don't really have to worry about these kind of problems, but technically that is how this works. Then the second element is also a nonmetal. That's a key feature of covalent naming, but that one's going to be the more electronegative atom, the one closer to the top right. All right, now then, the key thing that like makes covalent naming stand out are prefixes. You've heard of prefixes, right? English class, big English fans. You're going to use these things called prefixes. I'll show you the list of them next slide. But basically things like mono, di, tri. You're going to tell me how many. So like see up here how there's 2 N's. So if you were to say that out loud, you wouldn't just say nitrogen, kind of like how you said ionic naming. You got to tell me how many nitrogens you have. And you do that using the prefix. So di means 2. Di, that is, not like, you know what I'm saying. All right, now then you go to the next one, oxygen, and you're still gonna put ide, so that's similar to ionic naming. You still put the ide, but then yeah, tri. So 3, the prefix for 3 is tri. So dinitrogen trioxide. So this is what I was saying earlier, like beginning of class. I think covalent naming is a little easier. It's a little more intuitive. It's a little more obvious how you do it. What then gets trickier is when I throw them all together, people start wanting to do like these rules for like what we did on the warm-up. So that's where so more next class where I think you might start getting a little more confused. Okay, now then, what are the different prefixes you have to know? That's what this slide's trying to show you. So there are 10 prefixes you have to know. A lot of these, I mean, you have to memorize them, but fortunately a lot of these like you come across just in your everyday life. Like it's not as if you're memorizing something completely new. Meaning, if I said, hey, what's the prefix for 1? Mono, like yeah, actually that makes sense, right? Mono would mean 1. Di means 2. Tri, that means 3. Tetra, a tetrahedral. Some of you geometers out there, right? Then you got 4 sides. Penta, anybody seen the pentagon? So you drawn a pentagon, it's got 5 sides. know? Hexagon. Yeah, you know what I'm talking about. This guy's a big geometry. Hepta's a little less obvious. I don't know how many people are walking around knowing hepta means 7, but it does technically mean 7. Octa. How many legs does an octopus have? 8. Every day of the week, right? Nona, that one's a little rare. Nona and Deca. I forgive you if you didn't know what those ones were. I haven't seen those. Nona's 9, Deca's 10. A decade, yeah, actually, yeah, that's actually. What's up? Yeah. Actually, yeah, a good point. Yeah, I'll leave this slide up for the 4 minute. That's a good question. Yeah, that's a good point actually. Decade every 10 years. That's why Deca is 10. I haven't thought about that. So, anyways, now here are the examples. So, it's really like it can be that simple, right? So if we look at the first one, let's say I give you NO. All right. Well, what's the name of NO? Well, N is nitrogen, O is oxygen, and you're going to say monoxide. Now, an exception here, so make note of this thing in the top right corner. You do not use mono for the first element. Meaning, notice how it is not... Notice how it's not mononitrogen, monoxide. We just say nitrogen, monoxide. So if the first element's 1, you don't need to say mono. That way it just flows a little bit better, right? It's just kind of like a little bit of a shorthand. You look at our second example, nitrogen dioxide. So again, NO2. Again, notice how it's not mononitrogen dioxide. All right, I want to move on. I got a few examples I want to do for you. I actually don't have this in your note packet. I added this in. I think it's helpful to go through a few examples here. Up to you if you want to find a place to squeeze it into your notes, but this is something that's technically not in your notes. Anyways, nitrogen tribromide. So anybody think they know what that would be? Let's get the hand up, you know? Yeah, go ahead. Yeah, good. Nitrogen, well, that's N. Okay, you don't see a prefix, that means it's just 1. Tri, well, tri means 3. Bromide, that's talking about bromine. So NBr3. All right. Hexa, well, what's hexa mean? Oh, yeah, well, let me ask. Somebody think they got that one? Yeah, go ahead. B6Si, good. Because hexa, that means 6. Boron, that's B. Silicide, the I, that's talking about silicone, which is Si. So B6Si. Number 3, may think they got that? Raise your hand. Yeah, go ahead. Yeah, good. Chlorine, Cl, you don't see a prefix, that means it's just 1. Oxide, that's O, and then di means 2, ClO2. Now let's go the other way. Now they give you the chemical formula, so what would be the name here? You might think they got that? I think it's a little trickier going this way, I found, like saying the full word. Yeah, go ahead.
Selenium hexafluoride.
Se would be selenium. So it'd be sulfur, but you said the last part right. Hexafluoride, 6 is hexa,
Yeah, I got that.
and then F is fluoride, so sulfur hexafluoride. Number 14, and they got that? So 2, what's the prefix for 2? Di. Si, what's Si? Silicone.
Wait, it's S. Oh, and our slideshow is different. That's
Yeah, I left these out of your notes.
the slideshow though.
This should be the same slide deck though. Are you saying like the answer?
Yeah, it said, look at 13.
Oh.
Yeah, that's like.
Oh. Interesting. Oh, that's why you said. Oh, gosh. I actually don't know. I got these from some worksheet. They had the answers at the end. I don't know. All right. Anyways, disilicone, 6 is hexa. Br. It's bromide. All right. Last one. S is sulfur. Oh, somebody was saying. You're gonna say? Go ahead. Yeah, good. Sulfur tetrachloride. So sulfur, because that's a sulfur. You don't see a number next to it, so that's why there's not a mono or anything. And then chlorine, that's Cl, but then you got to put the ide ending, and then 4 is tetra. So you say sulfur tetrachloride. Okay. So again, you want to add those to your notes? Sure. Just want to give you a few practical examples. All right. Now there are a few exceptions, as there always is in life, right? So there are 3 exceptions that I need you to memorize. Those 3 exceptions are really 3, and then there's something with acids I got to tell you about. Those 3 are water, ammonia, and methane. And you know, like water, if I said, hey, water, chemical formula, I think most of you are like H2O. Got that? So water, like where the exceptions come in is people have been calling water H2O and H2O water before we formally made this system. So like dihydrogen monoxide, if I came up and said, hey, you want some dihydrogen monoxide? Does that sound like I'm about to poison you? Yeah. Like I'm trying to kill you? Technically, according to that naming system, dihydrogen monoxide, that's water. That's kind of a fun chemistry joke. If you want to like, gosh, somebody like, you get some like fancy like label, like there's chemicals in your food, you know? Dihydrogen monoxide, that's just water. Anyways, ammonia, that is NH3. Again, people have been calling ammonia since before then, so know that example. Methane, that is CH4, so that's one you got to memorize, not carbon tetrahydride. And then I'm going to jump to the next slide and show you the acids. This slide right here, not really new notes, but just kind of like a good summary slide. So first bullet point, use prefix to show me how many atoms. Second one there, change the ending to I, just like we do with ionic naming. And then number 3, check for the exceptions. So letter A there, let's talk about the acids. There are, these are the acids you have to memorize. So you got to memorize these along with these. Now, fortunately, these actually go together. Meaning like if you, so check this out. Hydrochloric acid, hydrogen, chloric, what does chloric sound a lot like?
Chlorine.
Sounds like chlorine, so hydrochloric acid, HCl. Now, how do you know it's 1H, 1Cl? Well, what's the charge of chlorine? -1, right? What's the charge of hydrogen? +1. That's why it's 1H, 1Cl. Sulfuric acid. What does sulfuric sound like? Sounds like sulfur, but it's referring to sulfate. What's the charge of sulfate? It's -2, right? What's the charge of hydrogen? +1, right? That's why you need 2 hydrogen. That's why it's H2SO4. Meaning, if you know these polyatomic ions, these acids actually kind of start to fall in place a little bit. Let's look at nitric acid. Nitric acid, that's coming from nitrates. What's the charge of nitrate? -1. That is why it is 1H going with the NO3, not 2. Carbonic acid. Carbonic acid comes from carbonate. What's the charge of carbonate? -2. So that's why it's H2CO3. Now the last one, acetic acid, aka vinegar. Guys, you know that vinegar comes from acetate. Acetic acid is just acetate. I'm almost done. Hang in with me, guys. I'm almost done. Guys. Acetic acid comes from acetate. Acetate's got a -1 charge. That's why there's just 1H. Now another way you can write acetate is like this. I don't care which way you have to write on the test or something, but just make sure you can write it.
So what's this?
Yeah.
We're supposed to memorize hydrochloric acid and sulfur.
Yes, so what I'm saying is you need to memorize these. I could give you on a test, I could say sulfuric acid. What is the chemical formula of sulfuric acid? And I expect you to say H2SO4. Or if I give you H2SO4 and ask what the name is, you got to say sulfuric acid. All right, last thing, This slide kind of brings it all together. So this slide is going to be a little more helpful for next class when we do mixed. But remember, ionic naming, metal plus nonmetal. So cation plus anion, balanced charges, covalent non-metal or metalloid. Technically, metalloids are part of this. Plus another non-metal. And you got to use the prefixes. Acids always start with H. So if you're like, is it an acid? If it starts with an H, it's an acid. And those are the acids you got to memorize. Diatomic. I made a little edit to your notes that I didn't catch. Made this a little more school appropriate for you. But remember, you got to memorize the diatomic elements. So I have no bright or clever friends, which you've actually, like, we learned about this on Unit 3. Remember, is this slide? So you got to still remember the diatomic elements. So that's part of the naming stuff. And then I showed you this slide before. I have some other mnemonics for diatomics. All right, I'm going to leave it up here on the prefixes. Let me know if you got questions.